DUCOM Biotribometer is one among our popular products widely used in implant biotribology because its purpose is to improve implant life. Let me take you through its design, basic principle of operation and applications. In the background, you are seeing a single station biotribometer and wear image of a ultra high molecular weight polyethylene after a million cycle of test. About biotribometer, it has a pin on disc or ball on disc contact covered with a leak-proof lubricant cup. The lubricant temperature is controlled by a combination of cartridge heater and thermocouples. Disc and lubricant cup are mounted on a linear stage. It can move along the X or and Y axis. Load is applied through a shaft connected to the pin holder. This shaft can also rotate the pin. Each station has its own set of sensors to measure deformation, wear and friction of pin and disc. Friction along the x-axis and y-axis is acquired to determine the average friction. The deformation and wear at the contact is measured and displayed as a function of time. Depending on the number of test stations, the biotribometer can be classified into a single station or 6-station biotribometer. Both of these designs comply with ASTM F732, ASTM G99, ISO 142421 gate load profiles. There are several functional features in biotribometers. Automated motion control is one of it. DUCOM biotribometers are available with a multi-axis stage common to all the stations. It can generate 7 types of motion: linear x-axis, linear y-axis, circular, figure 8 or butterfly, square, parabolic, and elliptical. Loading is computer controlled and it is not through dead weights. Load on the disc is controlled to achieve constant load, ramp load, step load, and any other customized load profiles if it is needed. For example, gate load profiles according to ISO standards. Note that ISO requires 3 kN of maximum load. However, in this biotribometer, the maximum load is 400 Newton. Each station can be fitted with a tribo-corrosion module. The disc will be the working electrode. We have designed two horizontal electrodes, a counter and reference electrode. All the holders and cups are made of electrically insulated composite material. This 3-electrode system measures corrosion current and other properties according to ASTM G5997. Lubricant recirculation system is possible. It can help in particle analysis and regeneration. Note that all these features are not a part of our basic unit. It might have to be ordered as optionals. Here is a summary of all the operating parameters that are possible in DUCOM Biotribometer. Why do we need a biotribometer compared to a conventional pin-on? This question can be better explained using two important parameters, that is, type of motion, it can range from simple to complex, and wear, which can be underestimated or being closer to clinical or in vivo data. If we are testing polyethylene biomaterial, the conventional pin-on disc with simple unidirectional motion will generate very low wear due to strain hardening of polymers. Whereas the complex motion profiles by biotribometer and simulator like butterfly or elliptical motion will generate wear closer to in vivo condition. However, simulator is used to test the design and materials together, whereas the biotribometer can only be used to study the effect of biomaterials. Here, an advantage is that the time and money is saved by using biotribometer. However, it is interesting to note that the mechanism of wear remains to be the same. In this table, we compare the wear rate, friction coefficient and wear mechanisms to prove that biotribometer is closer to a simulator.